Hi everyone, so this video is to practice Hardy-Weinberg equilibrium problems. And the first example we're going to cover here is the following. So it says here, in Drosophila, the allele for normal length wings is dominant over the allele for vestigial wings. So vestigial wings are short, stubby, little curly wings that cannot be used for flight. In a population of 1,000 individuals, 360 show the recessive phenotype. How many individuals would you expect to be homozygous and heterozygous for this trait? So keep in mind when trying to solve Hardy-Weinberg problems, you really have to figure out the proportion of individuals in the population that exhibit the recessive phenotype. So in this example, they are telling you that out of 1,000 individuals, 360 show the recessive phenotype, which is this vestigial wing shape. Okay, so the first thing, again, figuring out the percentage of individuals that are recessive. So if you take the 360 vestigial wings out of the total population, you get 36%. When we express this as a decimal, that's 0.36. So dividing 360 by 1,000 will get you 0.36. Now here's the real trick to Hardy-Weinberg. You have to realize that 0.36 is the frequency of homozygous recessive individuals. So QQ, little q, or Q squared. So 0.36 equals Q squared. Now to figure out what Q is, you need to take the square root of this 0.36. So taking the square root of 0.36 will get you Q, and it turns out that this is 0.6. Okay, so Q equals 0.6. Now recall that P plus Q equals 1. So if we know that Q equals 0.6, we can take 1 minus 0.6 to figure out what P is. So in this case, P would be 0.4. So now we have the allele frequencies that we need to solve this problem. Okay, so I'm going to put this over here. P equals 0.4, Q equals 0.6. Let's make some space to work. Because what it's going to ask us now is the frequency of certain genotypes in this population based on the allele frequencies, which we said were over here. So to do this, you have to recall P squared plus 2PQ plus Q squared equals 1. And so just keep in mind homozygous dominant individuals, heterozygotes, homozygous recessives. Okay, so we already know what this is. They gave us this to start. Q squared equals 360. But what about the homozygous dominant and the heterozygotes? Okay, so to do that, we simply take our allele frequencies and plug them in. So here we would see P squared is 0.4 squared, and the heterozygotes would be 2 times 0.4 times 0.6. So that'll give you the answer for each of those once you do the math. If you do the math here, you'll get 0.16, and here it'll be 0.48. So that's saying 16% will be homozygous dominant, 48% will be heterozygous, and because 1,000 is a nice workable number, you would see that 160 out of 1,000 would be homozygous dominant, and 480 would be heterozygous. Now keep in mind, we knew this number already, 360. The population is 1,000, so we need to double check our math. If you add this, this, and this together, it'll equal 1,000, and that'll let you know that you've done this correctly. Okay, so I hope that helps. Remember, the key is to figure out what Q squared is in the population and work it out from there. See you next time.